And that is the most controversial thing that I will ever say in the classroom. Please don't get me fired. Cool. All right. So on number 57 from the assignment, you were dealing with f of x, and we just did this as the bell ringer. But f of x is 2 sine x plus cos x. Is that correct? Okay. And immediately we jumped to f prime of x is 2 cosine of x minus sine x. Now, what is a horizontal tangent line like? And there's a million ways you can answer that, right? What does it actually ask me to find? Where the slope is 0 and the derivative gives me the slope. So essentially, with way more words, find the zeros of f prime. Okay, so let's find the zeros of f prime. Now, I do not have a great memory. You've probably noticed that. I assume you've noticed that. For whatever reason, math stuff seems to stick pretty well, but not constantly. If I do this, I am just going to jump in. Here's our writing. What's the issue that I have with this right now? Why is this hard to solve? It's not rhetorical. I'm not trying to like trick you or nothing. Like, what makes this hard to solve? Cosine and sine. It's like I'm trying to solve this for x, and this is a very different problem, but same basic idea. I have two things that I'm trying to deal with, but they don't match. So we need a way to make them match, right? Now, the good news is that if I think all the way back, and I don't have a memory for it, but do you guys have your textbooks today? I want to check something in here, and I'm going to go to the very back, and let me look before I make you do it. Yeah, go to the very back, and then go like 3 pages. So you'll see a bunch of ugly, they're called integrals. You don't know what they are. You'll work a little back. You'll see a table of derivatives. And if you go one more page, you have a handout very similar to this. Not exactly, but similar at least. Okay, so what have I directed you to? The unit circle and identities and such, right? Okay, so as we're looking through this, when I see cosine and sine and they don't match, my first thought is maybe there's an identity that we can use to make this a little bit nicer. Okay, everybody all right with that? Now, what I want you to do, and whether it's the right one or not, I want you, looking at that reference sheet, see if there's anything that we could possibly try to plug in here. And I'll give you guys a moment to find it, or to look around, and whether it's the right one or not, I'm not super worried about it, but we're going to try to get them answered. Because I'm just looking for anything that I can do to fix this. You say tan. Why? So if I add a sine, so I'm apprehensive to do that, and there's only one reason. If you didn't catch what Sean said, his suggestion was we can add a sine to each side, and we get this, right? And then maybe we divide by cosine x. Okay, there's a little caveat that I need to pay attention to. And if you've ever seen a proof where somebody says 1 plus 1 is equal to 3 or something like that, like the proofs that look right and it seems okay, there's a fundamental mistake that everybody always makes, intentionally, I think, to cheat through it. When I look at this problem, I'm going to go back and I'm going to check the interval that we're on. So we're on the open interval, or closed interval, I'm sorry, from negative 2 pi to 2 pi. Here's my concern. Is it possible that cosine of x is 0? Now, when it's possible that the cosine of x is 0, is it possible then that I just divided by 0? And I would be worried about that. Now, I like the idea, Sean, and I agree that it seems okay, but it's no different than if we have something like this. If we had x squared plus x equals 0, we factor to solve, right? We don't divide each side by x, because if x were 0, we can't do this. Okay, so that same logic is happening here. Does that make sense? All right, so love the idea, but I don't know that we're allowed to do it. So I'm open to other thoughts. Now, they're not always obvious, right? And that's okay. I have an equality on the board. If I do something to one side, can I do it to both sides? I think so, right? Okay, so as I'm looking at this, there's a few different options that I can go with. Cosine and sine, there's no identity that looks exactly like this in the back of your text. Like, it just doesn't exist. But if we could get a cosine squared or a sine squared or something, it would be super convenient. Do you guys agree with that? Well, since we already have equality, and this is, I haven't looked, I'm just going off the cuff here. I think we probably multiply by something on both sides of the equation. And in doing so, if I can get me a cosine squared or a sine squared or some variation of any of those trig identities, we might be able to rewrite stuff using only sine or cosine. That's where my head's at right now. I know what I would want to multiply by, and you might not yet, but in my mind, there's two obvious choices that we might try. Cosine is reasonable, or you can do cosine plus sine, it's kind of like the conjugate. We can multiply by cosine, or sine, or cosine plus sine. I don't know which one's going to take us down the right path. My guess is they probably all will. Some of them will be nicer than the others. What do you guys want to multiply by? You want to try the conjugate? Let's try it. Now, I would, like, as I'm looking at it, we'll try the conjugate. I don't know how it'll shake out. I think it's going to mix my sines and cosines together more if I do that. Is there any identity in that back sheet that has a 2 cosine and something else? So 2 cosine squared is one of them, right? 2 cosine squared, I don't remember it off the top of my head. Where my mind goes to immediately, just because I don't remember all those identities, I think that if I can get a 2 sine x cos x, that's a sine of a double angle, sine of 2 theta. Like, that's the one that my brain clicks to first. After talking this out, the conjugate, let's try it, let's see if it shakes out, but I do think it's gonna muddy the water a little bit. But let's check it. Okay, and it's okay to be wrong, right? Like, there's no consequences here. I'm going to multiply both sides of this by the conjugate. Do you want me to use 2 cosine plus sine or just cosine plus sine? There's no wrong answer. We're just trying stuff. Sure, let's try it. 2 cosine of x plus sine x. And I'll do it to this side as well. Now, this one, if you feel like it's the same thing that we were trying to do initially, as Sean suggested, which love the suggestion, are we dividing by anything? So I don't have to worry about that happening here. All right, so I'll do the left. I want you guys to do the right side. And I'll pause it for a little editing magic. All right, we've not cheated. We haven't done anything that's not allowed. We've just used the multiplication property of equality. Cool. What now? There's a couple of options. You're looking like I'm going to tell you. I'm not. Talk it out. I don't care what the suggestion is, but talk with your neighbors. Let's see if we can't come up with something to try. Love that thought. Try it. Let's see what happens. I assume that's what we're going to do. What do you think? Did you? Oh, really? Oh, okay. Yep. So we should make a collective decision, whichever way we go. I know that sine squared plus cos squared is 1. So I can either replace cosine squared with some sine squared stuff, or I can replace the sine squared with cos squared. I'm going to check what they did, and we'll just go with whatever squared I told them to start with. Did you already start too? Okay, you guys over there, Rafa, your idea right off the bat is what I want to try. Rafa suggested Pythagorean identities, and we're using the fact that sine squared plus cos squared is 1. Collectively, so we all do the same thing, are we going to replace sine squared or cosine squared? Replace sine squared? Okay, so if you are not super comfortable with trig or whatever, I should leave it on the board so people can see it. My lapel mic is on the way, and I'm super excited, by the way. I bought a wireless microphone so that I can walk around and not be worried about my voice trailing off. Yeah, we're getting fancy. All right, we're going to use this little fact. Sine squared plus cos squared is what? Is always 1, and you guys say we're going to change sign. So what should I subtract from both sides? So sine squared is 1 minus cos squared. Okay, let's try this substitution. Let's just see if it works. I'm going to replace this sine squared with this. Now, if you are not super careful, there's a really common mistake that people are likely to make. Can anybody tell me the mistake that I'm concerned with right now? This parentheses, right? So I'm going to replace it with minus, and I'll do 2 steps with the understanding that maybe you would do this in a single step. I think this is going to come 5 cosine squared x minus 1. Somebody second Again, don't just blindly trust. I didn't look at any of this problem. I have no idea. It's going to be really a shame if we're wrong in the end. This is good stuff. Miss Cabal, agree or disagree? Where are you hesitant to commit one way? Like, I very well mind being a mistake. Are you okay with up to here? And here? And here is where you're getting a little apprehensive. Okay, so just to show you what I've done, if I distribute this, I get a -1 and a plus cosine squared. So I'm just combining all my like terms. I might have misread your face, my bad. Cool. All right. Now what? Yeah, I'm going to do 2 steps. I'm going to move the 1, but I'm going to do one more thing. I'm going to divide by 5. So my very next line, if I add 1 and divide by 5, I get 1/5 is equal to cosine squared x. Still feeling okay? All right. Well, let's keep kicking because I think the end is in sight. And whether or not it's exactly what the back of the book says, we'll check. I bet it is. I have a feeling that we didn't cheat through this anywhere. We'll see how it shakes out. Their answer had tangent in it. I don't know. I don't see a tangent, but we did the problem differently. That's okay. All right. What did you do to both sides? Square root. Anything I should put here before I write the square root? Or is there anything that I should put in front of the square root? Plus or minus? Okay, equals cosine of x. Okay. Now, in this, I don't know about you guys, but I don't remember root 5 over 5 ever showing up on the unit circle. Or 1 over root 5, however you want to word it. Like, it just doesn't, right? Gosh, well, if only there were a way to find the value of x. How do you undo a cosine? You take the arc cosine, or the inverse cosine. I'm going to do that to both sides, and it's going to look ugly for a second. Remember, whether it's arc cosine or inverse cosine, they're the same thing. I always use a capital C when I do it, so I don't confuse it. Here's the arc cosine of this side. And it's going to be ugly, but I'm going to take the arc cosine of this side. And huge moment of truth here coming up. I don't have no idea what the right side is, or the left side, I'm sorry. Not a clue. However, what happens to the right side? It's just x. Now, we're going to shift to our calculators because I don't know this number off the top of my head. But there's a very, 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 very important thing that we need to check first. When we're doing this, they didn't specify, they didn't tell me that I'm working with a degree or a radian. Not directly anyway. On the problem, however, I see that we are asked to work on the closed interval from -2 pi to 2 pi. That right there tells me that we're in which mode? We should be in radians. So let's go ahead and, uh-oh, why aren't you moving? There we go. Oh, it does work. Okay, so on our wonderful calculators, check it out. I'm going to turn it on, and the very first thing I'm going to do is I'm going to hit this mode button. And I'm going to double check. I'm dealing with functions. Uh-oh, mine's in degrees. Don't love it. I'm going to hit to the right, and I'm going to go to radians, hit enter, and hit enter again to save it. Mode. I'll look to make sure that radian is what's written here. Yours might have been on radians already. I have no idea. Okay, so now, big moment of truth here. I'm confident in our answer, just so you know. We didn't do anything wrong. It's not going to look exactly like the books. I have no idea how they did it. Did you guys check the answer key? Did they divide by cosine at the beginning? Is that what they did? That should not be allowed. Between -2 pi and pi? I don't like that. Okay, but let's check. I'm trying to find the arc cosine of something. Where on earth would I find the arc cosine? Diamond. So diamond and cosine, here it is. Cool. The arc cosine. Now I'm going to do one positive, one negative. It's the square root of 1/5. That's what we had, right? So 1/5, I closed left and right, and now left and right. Okay, I'm going to hit enter, and my calculator doesn't really give me anything meaningful. Did yours do the same thing? What if I wanted a value to it? You could do a comma. We don't have to. We wouldn't do a comma. We don't have to tell it with respect to anything because we know what it's already doing. It's just evaluating. But if I want an approximate answer, diamond enter. And we're going to double check. So here's one of them. What's the other thing I need to do? Negative. So all I need is just here. I'm going to sneak a negative in front. I'll do the positive and the negative. And I see two wonderful numbers. Okay. Your book. Let's double check and see if we got the exact same thing. And if we didn't, I'm not sure why. I don't like the idea of dividing by cosine because I think that that is risky and we shouldn't do it there. But let's dig in here. On 57, oh, they have very similar stuff. Their answer is awful. It looks awful, right? Okay, so they use tangent at some point. I'm going to check real quick what the square root of 5 is, and I have a pretty good feeling. I'm not certain, but I think it might be 2.03. That seems like it's a little small to me, but let's check. Okay, so I'm just going to see what the calculator, or the answer in the back, this said the arctangent of 2. Arctangent of 2 is one of their solutions. Hey, well, that's pretty cool. That's the same answer. Is root 5 really 2.03? That seems so small. And I'm using root 5. That number's not coming out of nowhere. It's because they tell me that it's the arctangent of this plus 2n pi, which they're in a closed interval. I think they made a typo here. You don't need the plus 2n pi because you're only between those two values. And then root 5. And I'm trying to figure out what were they actually asking because their answers look weird. On A, graph the function on the interval. They didn't graph it. They didn't show the graphs. Sorry, I'm just trying to make sense of what it is. Find all points on which it is. Okay, so there's our first one. Trying to make sense of what this number is supposed to be. Root 5. Let me think about this. I don't have an answer right off the top of my head on what exactly it is that they're trying to say. This comma root 5 part I don't quite get. Let me think about it. We'll come back to it. I feel good where we're at purely because at least the first answer matched. I don't quite get what they're saying here. I'll report back to you guys, okay? Cool. All right. So that's a good problem. I hate that they divided by cosine. That bothers me. Okay. Regardless, you said 57. We looked at the first part. I'm going to click around. I'll see. I think I guarantee our answer is right. I don't know what their answer is expressing here. Or is everybody okay with that? Like rather than just spinning our wheels, like we got one of them, I'm sure the other one's right as well. Okay, here then. What was the other one you wanted to do? 63? Why? I don't know how to answer that. Oh man, this problem's so hard looking. It's not. And we're going to make sense of it. Love it. These problems, first time I think we've seen it. These are really common on the AP test. You will have a problem exactly like this. Forget about the cosine part. What does this look like to you? Just x plus h, x, and h with a limit. That looks like a derivative, right? Everybody agree that on number 63, it's very clearly the limit that gives us the derivative. Now, they're trying to find it at a particular point, it seems. Can you tell me which point they're trying to evaluate the derivative at? So they're trying to find the derivative at pi halves. Everybody's still cool with that. What function are they trying to differentiate? Well, let's not do it that way because we don't want to do limits anymore, I don't think. Do you guys know the derivative of cosine? So here we go. Let's simplify this problem. And this is legitimately, I imagine, what they want us to do. F of x is cosine. Okay. Which means f prime, without doing a big ugly limit, we know it's negative sine x. And they're trying to evaluate this at what number? Pi halves? What's the sign of pi halves? So, two answers. I think you both gave me correct answers, but in different situations. You said one and negative one. I think, Sean, you're answering the whole question. I think you're answering just the unit circle question. Here's 0. Here's pi halves. What's the y value? 1. And Sean, you notice that it was a negative in front of it. And there's our negative 1. I think it's negative 1. I sure hope it's negative 1. We're going to check the answer.
Wait, so
That's it. Yes, it was negative 1. Cool. Those problems, they seem so like awful. If you are comfortable with how we define stuff, and seemingly you guys are because you were able to answer every single question that I asked there, did you guys recognize it while you were doing it that it was a derivative? Okay, cool. Real quickly, we're going to do this one just because we can. They're trying to find sine, the derivative of sine at which value? Pi. So what's the derivative of sine? Cosine and cosine of pi? Negative 1. Boom. 64 is negative 1. Without doing the limit, as long as we recognize that this is just a derivative, we're golden. Cool. All right. I will go ahead and hook you guys up with a class-wide practice test that will work together. And I wasn't sure which way you guys are going to go, but I prepped for both. And let's dig in. So I'm going to pause it as we're distributing. If you guys are watching this on the road, on the Google Classroom, if we refresh it, nope, it's already here. Calculus Chapter 2 practice test. This is what we're going to work through together. Now, kind of close if we're going to get through all of it or not, but we'll see with that one. All right. Anyway, enough about Greek epic poems. I want this function to be differentiable at a point C. In order for this to be true, what must happen about this limit, do you think? Does it need to be finite? Okay. Does it need to be equal to 0? No. Does it have to equal the x value that we're approaching? So I don't think so. Abigail, I couldn't tell if you were nodding yes or no. I just couldn't get a read. Maybe you were just singing in your head. I don't know. But does the limit have to exist? It has to. This is it. It's D, 100%. Oh, we're going to get crazy. Nope, doesn't understand. Ooh, that's a great question. Kalisha? She's not here. What is differentiable? To take the derivative. This is the actual word that we use to say to differentiate or to take the derivative. Yep. We're not going to say the other one. Cool. It's D. It has to be. Questions about that one? All right. Do you want to do the whole thing together, or do you guys want a few minutes to work through it together, and then we can address any questions that we have in like 15 minutes? I'm okay either way. I just don't know if this is boring for you. Maybe it's calc, whatever. Like as a whole class? Okay, well, I'm good with that. Yeah. All right. Here we go. We got to match some of these with some justifications. When you guys look at problems like this, not right or wrong, do you look at the word and then try to find it, or do you read the justification and then you try to think about which word it would be? Are we going to find whichever one is jump, or are we going to find whichever one is A first? Okay. So the slope of the secant lines approach infinity from one side and negative infinity to the other. The slopes, they get positive and negative like this. Positive infinity, negative infinity. So I have up here, I'm throwing out signs, right? But I'll draw it. This one, what I see is if I'm thinking of a function that does that, I see that it gets really steep and really steep. Something like this. This, to me, let's think. This is the derivative that we're seeing, right? Okay. Is that a jump discontinuity? You may be tempted to say yes. It's not. This one is much more tempting to say yes to. Is it an infinite discontinuity? Somebody inevitably is thinking yes, because it does look like it. But again, I want to stress, what did I draw here? This is f prime. This is the derivative. I see the slope gets really big and then really negative. Okay, if we're looking at that, because we're not talking about the function f, I don't want to say it's necessarily an infinite discontinuity. It could be. We've not talked about continuity of derivatives yet, but all the same rules apply, so maybe. Let's see. Any other words that it looks like it could be? A cusp. If we think about what a cusp looks like for f, cusps are something like this. Does this slope get super negative and then super positive? Hey, it is a cusp. That's A. Nice job, Rafa. Okay. Now, again, I don't know you guys, seemingly at least one person in here, whoever suggested it the loudest. You want to go from here to here? I'm good with that. Cool. The limit from the left is equal to the limit from the right, but they don't connect. So let's see if I can do this. Oh, it's not going to let me, but we can do it on this other one. What? Okay. Oh, there I am. Weird. There we go. Oh, look at me spinning. Cool. All right. Check it out. Limit from the left. Limit from the right. Like they meet the same number, but they're not pointing at my head. That's what this picture is telling us. Left and right are equal, but there's no fill-in. What is this showing is the question. So let's take a look. Removable? Maybe. Could be removable. Let's see if there's any others that it could be, just before we commit to it. Okay. I think possible. I like that one. Is that a jump disco? Not if they get to the same number, so that one's out. Is it continuous? It's actually discontinuity. Not a corner, not a... Yep, Sean, I think I agree with you. I think it's a removable discontinuity. Now, I'm going to be honest, I agreed with you right at the get-go, but I want to make sure that we do go through all of them just to double check. Cool. All right, look at us. We're cooking. Bless. All right, this time it's the same thing, but they do close. That is the definition of continuity for sure. Awesome. All right. What if they don't match left and right? So it's like that staggered bonk. That's a jump for sure. Jump discontinuity. Goodness, syllables. All right. The one-sided derivatives. They exist and they're finite, but they're different. So same thing that we can look at. When I think about this picture, I think of something like this is what f prime would look like. Like different, but finite. If this is f prime, anybody remember the type of functions that this happened with? So the slope is the same the whole way down here, right? It's positive in this situation, and this is a weird one. But the slope is positive. So here is the graph of f. My slope is positive everywhere. That's like a positive 2 slope, maybe if that was 2. And then all of a sudden it changes to being a negative slope. What do we see here? It looks like an absolute value. Sean, what did you say? Because you were right. It looks like a corner, doesn't it? Boom. The 3 ways that these fail to exist: cusps, corners, and what's the other one? Vertical tangents. There we go. All right. So we're done there. Baller. Hey, speaking of, let's look. Limit as we go from the left is positive for negative infinity, or from the right is positive for negative infinity. Now, that situation, it could be the same here. It's something like this. That didn't do what I wanted it to. I can't control Z on this. I hate it. All right. I'm going to ask you guys while I'm struggling with this, chat with your neighbors. We have 2 more. If it has to be a guess, sure. But I'm going to give you like 30 seconds. See if you can come to a determination, and I'll ask somebody for their explanation. Love the conversation on that side. This side, not as much. If the slopes get infinitely big, which is me looking at which one? G. The slopes get really big. Eventually, do they get so big and so steep that we can't even talk about the slope anymore? Because eventually it gets so steep that it's just straight up and down, right? And that's not defined. That's a vertical tangent line. I think 8 has to be G. Now, like I've already written it. I was going to say before we write it, we should think about it and check the other one as well, but we've already committed to it. My bad. Let's see. If I see that from the left it's infinity and to the right it's infinity, something like this, is that a continuous function? If it's f, and I'll draw it here. I don't know why I don't just draw it. If here's a graph of f that approaches infinity and infinity, is this continuous? No, it's not a jump. It's not removable. It's a what? F infinite. Boom. We have it. Sweet. Love me some good matching problems. Now, questions about any of these? They feel okay. I assume everything probably feels fine if I'm up here talking through it. It's a different story when you try it on your own, but as long as you guys are engaging, it's not just me doing the problem, I think there's value here. All right, we want to find the equation of the tangent and normal lines for each of the following, or for the following, and they want us to use that to calculate the slope. Now, if it specifies use this to find the slope, you need to use it, right? Now, we can think out a little bit in our head, though. I'm trying to calculate the slope when c is 2. Right off the bat, we're not going to do the problem this way, but we're going to check it this way. Can you tell me the derivative of this? 2x. And if we were to plug in 2, we should get a 4. So I know that here in a minute when we do the limit, what should we get? 4, because we're going to do the limit at 2. Okay, so let's try it. So here we go. We're going to use this formula, and notice it's similar to the x plus h. They're just happening to mix both of them. But let's try it out. The limit as h approaches 0 of f of, what is c going to be? 2 plus h minus f of 2 all over h. The first step, let's just plug it in. Now, I'm going to do a little bit of scratch work off on the side because I don't want it to happen in my problem. So I'll just go ahead and say, check it out. Here's some scratch. And let's do a little bit of work. Here's my function, f, or y in this case. They're interchangeable. I need to know what is f of 2 plus h. That's the big one that I need. And the follow-up is, anybody in here a freshman? Good. Cool. I'll give you guys a second. Let you get a little practice with distributing and foiling and stuff. So here's the scratch work. I foiled it out, and let's just continue on. We'll take the limit as h approaches 0 of, I'm just going to plug in this value. It's h squared plus 4h plus 8 minus, you guys said it was 8 all over h. Peace out. They gone. I'm going to do 2 steps, even though I wouldn't normally. This is now the limit as h approaches 0. Anything I can factor out of the numerator. And h leaves behind an h plus 4. Divided by h, they also gone. And now let's let h go to 0 plus 4, 4. Which is exactly what we found, right? Okay, so there's step 1 of this problem. And they don't break it into part A, part B, part C like I normally do. But that's okay. We need the slope. Now, we also know that we have a slope here, and it runs through, and we'll do tangent first. The tangent. What is the slope of my tangent line when c is 2? 4. And if you want to find the equation of a line, you need the slope. So I got it. The slope m equals 4. What else do you need to write the equation of a line, though? It could be the y-intercept. I don't know it, unfortunately. We need at least a point. Now, if it's a y-intercept, that's awesome because I'm just going to use mx plus b. But if it's not the y-intercept, that's also awesome because we can make it work. I know this runs through the point 2, 4. Because when I plug in a 2, it spits out a 4. There it is. Gosh, if I knew point and slope, I could probably find an equation of a line. Oh, point slope. Gosh, but here I am. I don't remember it. Good call, by the way. It is point slope. What? So y minus y1, or 4 in this case, equals m x minus 2. We're done. Now, you don't feel done because everybody naturally wants to go one step further and solve it for y. But if I don't tell you in slope-intercept, I don't care. Okay, the normal line. What does that even mean? What on earth is a normal line? So, love it. The opposite reciprocal. It's perpendicular to my tangent. All I need to change is this. What's perpendicular to a slope of 4? So here we go. Y minus 4 is equal to negative 1/4 times x minus 2. And we're done. Cool. Easy peasy, super hard. Maybe not super duper easy, but any questions on that first page before we move on? Okay. Show me with your hands what it means for a function to be continuous. Love it. Okay. If you join him here, I'm fine with that, realistically. I poked way harder than I should have just now, and it didn't feel good. So is it continuous? We do that hand gesture to show the left and the right and f of. Like, that's what that is really representing. So let's check this out. I want to know, is it continuous at 1? It means I need to take the limit as x approaches 1 from which side? Both. Love it. I'm going to do left first. Now, I'm just going to write, I was going to write f of x, but let's think this out. Give me something to the left of 1. 0. If it's 0, does that fit the top functions, boundary, rule, constraint, whatever word you want to use here, or does it fit the bottom functions, boundary, or rule? Top. So when I type in when I write the function here, I'm going to write x squared plus 1. Now, everybody cool with that? Okay. What is the limit as x approaches 1 from the left of x squared plus 1? 2? 1 squared plus 1. Yep, that's 2. Cool. I'm going to change colors. We should probably do the same thing where? From the right. And what function would you use if you were using, which part of this, rather, if we're approaching it from the right? The bottom one? I'm cool with that. X plus 3. And what's this limit? 4. Now, I don't really know that I need the third part anymore. If these don't match, is there any chance that f of c or f of 1 in this situation is going to be the exact same as both of them? No. So I'm not going to go any further. What would we conclude? It is not continuous at x equals 1. So implies not continuous at x equals 1. Can you tell me more specifically what type of discontinuity it was? It's a jump discontinuity is what we're seeing. Cool. All right. This one is nice. We didn't go into crazy detail about this because we'll see if we did need to. I didn't think we really needed it. Because if we understand that derivatives are limits and we can do left and right limits, we can certainly do left and right derivatives. If I wanted to find f prime of x, and I'm going to put a negative here. This is just a made-up notation. That's to show me from the left. Top or bottom function? Good. What's the derivative? 2x. I'm good with that. And now if we wanted to find it at x equals 1, we would do f prime of 1. I think it's 2. And I don't know the right way to denote this. It's not a common notation. I can't decide what I think is the right way to do it. If there's a negative, I assume we're all going to think it's from the left. I'll also do digging there because I don't know that true notation. Okay, what about the right derivative at 1? I'm just going to do it like this. F prime of 1 from the right. 1, because the derivative is just 1. No matter what x I pick, it's 1. Okay. So there's that question. Now, differentiability and continuity are very similar ideas. Continuity is typically what we use to talk about f. Differentiability is where we talk about f prime, but the ideas certainly overlap. Does a limit from the left for the derivative, and this is me saying the derivative from the left, the limit of f from the left and right, were they the same if we think about the derivatives? So from the left it was 2, from the right it was 1. Or did they match? If they didn't match, does that limit exist? Which means when we're really, I'm using limit and derivative interchangeably here. If the limit didn't exist, can the derivative exist? No. So here we go. Is or is not? Why? Because I heard, I'm just looking for different explanations, and I heard several people. Sean, what was yours? Because? Abigail, you said something as well, I just didn't catch it. It's not continuous. The derivative isn't, right? Now, you're correct. We have a much easier way to say it. F prime, and I'm just going to write it differently here, from the left, did not equal f prime from the right. And Abigail, you're absolutely right that we could say f prime is not continuous, and that's what this is saying. But this is a much more concise and clear answer, I hope. Maybe not more clear, but definitely less writing. Okay. Cool. We have about 60 seconds. I want you guys to give me 30 minutes of work on this one tonight so that you can come with specific questions tomorrow. Tomorrow in class, whether we just use the conclusion of this for the rest of the practice test or if we do a whole nother practice test, I'm flexible with. I'm not set in stone either way. Whatever is going to make you guys feel more comfortable with the material is really what I'd rather do. But 30 minutes on this evening. Tomorrow, hopefully you come with questions about it. Okay, hard limit, 30 minutes. Stop there. Cool.